So, Riley made the choice, so guess what's on the bench tonight? A big hunkin' boat-anchored power supply with lots of transistors in it. We'll see what's inside. Okay, so what do we have here is a Trygon power supply, 52, so it's 50 volts, 2 amps. And this thing is built like the proverbial brick shithouse. Ooh, it is heavy. A lot of iron in that transformer. And look at that turret board setup and everything else. I'll go commando for a minute and we can see closer up on the board to get a good idea. But you know, look at the quality here. All these nice little tie wraps on the wiring. You know, you just don't see this anymore, ever. Maybe on some Mil-spec stuff, but not any consumer electronics or even high-end electronics these days, high-end instruments these days. This is like built above tech standards. Anyway, let's go commando. So here I am zoomed in close, and you can see the turret boards here. And look at each individual one of these resistors was picked out as silver, so they're all 10%, 1% resistors. The wrapping there, they even bent the little wires everywhere to give the right spacing for heat. God, this thing is built beautifully. Right. The most impressive part is on the inside. Let me flip her over here and get a better view of it. Ugh. Look at the rheostat for the voltage control. That is a full-fledged Variac. I'll go get my other one and I can show you what that one looks like, because that's exactly the same part number. So I went around the back of the shop and there you can see a Variac, which is almost exactly the same as the one that's in there. You know, that's just a big hunk of iron. You know, you could use that as your benchtop Variac. Anyway, look at the size of the capacitors in there. Okay, well, let's carry on as if we're normal and go back to normal side. Look at the power resistor there. I'm just so impressed with this. Gold-plated banana jack plugs, banana jacks. Egad. Variac is just smooth as glass. So is that. No sticky here, and the switches really go clunk. Nice aircraft grade switches. Oh well, let's get back to normal mode. We can do the next little thing we have to get done. So normally when I do one of these things, the first thing I want to check to make sure the transformers are all okay and the fuses are all okay. The chap I got this from said he'd already did all those checks, and I kind of believe him. He's not that bad. He's just like a little over his head when he gets into this kind of stuff, as he's never worked with it, and he's a little afraid of high voltage, not being experienced with it. So I'm going to dispense with that. So one thing is to know about these power supplies is they're not like your typical modern day benchtop power supply for lab work. They were normally made to supply 1 voltage at 1 amperage for some big project you were doing. So you'd have this next to, say, a radar set or something you were trying to build, and this would take the place of the power supply. So you could build whatever and not have to worry about having a power supply handy. So that's what these were designed for. They're also designed to power certain things constantly. So they weren't really designed to be a lab benchtop power supply. So what that means is that a lot of them require a load to draw any current or voltage. So my buddy who looked at this might have just got it wrong and not put this on a load to see if any voltage comes out. So that's what I'm going to set up next. Okay, everything's set up for the test now on this one. I've got it set up through my isolation transformer coming down into a double switch. Coming into here, and basically I just have 2 banana plugs going in there and going over to this big hunkin' power resistor, which should just put a nice dummy load on there. So I'll turn the master switch on, throw the switch with my plastic button here, and try the voltage adjust. Nothing. Okay, so that is dead. There's nothing coming out of there. Turn that off, turn that off. Now the other thing, it might require you setting up a positive sense. And again, what we do in that sense is we just short out the power supply like that and throw it back on again, and then we set the voltage to what we want. Nope, we're not getting any voltage. Ooh, and no ampage either, so definitely not working. Okay, so off to the interweeb I go to see if I can find a schematic which will give me a little more idea what's going on.
Turns out trying to find a schematic for this particular power supply was a little difficult. A quick Google search revealed none coming up right away, though of course there were some for sale on eBay, but given the about $30 Canadian sales price plus about $30 shipping, it's not really worth my while to pick one of those up. The good old Boat Anchor Archive did happen to have the schematic for the lower voltage and lower amperage version, which I downloaded. And after a lot more searching, I found one for the L3540, which was the 40 volt 2 amp version, so I got that one as well. Also, from one of the eBay sales, I managed to scan a picture of the schematic for the lower amperage version of this power supply and the block diagram. Fortunately, the block diagram for this and the T40 were basically the same, so I might be able to get a little information from that. We'll see.
As we saw in that interlude, I did find some schematics, but the big difference is all of these are for the lower voltage ones, the 750 mil ones, not these high voltage 2 amp ones. Even though the circuits are somewhat the same, and even the circuit diagram and the block diagram, as I saw, are quite the same. Big difference I discovered between this one and these is I only can find 10 transistors in this one, where these ones all have 11. So, what do we do? Well, we go back to first principles. We get out our lab notebook. And we write down, not sure if you can see all that, yeah, we write down all sorts of voltages and stuff that we want to take. We can test at least voltages coming out of the transformers and on the capacitors. There's actually a C3, but I just can't get at it. It's stuck right in the back, so I don't have to worry about that one. Then we check all the diodes. I found like 12 diodes in this thing. And then we check all the transistors to make sure they're all okay. So I'm just going to start doing that. And when I'm done, I'll come back. If I find anything interesting while I'm doing that, I'll come back and tell you. So I'm finished doing my initial voltage checks, and of course I was kind of back-assward on this. Believe it or not, this small little transformer over here, plug that just to make sure. This small little transformer over here is the mains transformer, so it's 120 volts coming in there, putting 25, 25, and 50 across there. And that goes into this big transformer here on 1 and 2. This big ass transformer here, 1 and 2. So you get about 47 volts and 50 volts come out this end. So that's all working correct. Now I checked the other capacitors and they're getting AC on them, 50 volts and 30 volts. The only odd thing I noticed, this one will drain once you unplug and turn it off, but the other one in there doesn't drain when you turn it off. It just sits there and stays charged, so it doesn't have any direct link to ground anywhere on it. That might be significant. So the next thing to do is start checking all these transistors. Now the great thing about when they built these things all these years ago was they built them for maintenance. And these transistors are socketed. I checked on the inside. You can see there they're in sockets. And you can see that the emitter come out there. So all you have to do is unscrew them. And test them that way. Now I'm going to set up a special test for this. It's a little A little grease down there, but not much. I'm going to set up a special tester I have just for these things. So I'll put that back for now, because you never want to... The other great thing about when they design these things is you can't put these transistors in backwards. The holes don't line up. You can, but they can't screw them in. So I'll put that back in there for now. And I'll get set up with my other tester. So here we are set up. I've got my handy dandy transistor identifier. Doesn't really test it for anything, but it does identify your transistor just by sticking it in here. In this case, stick that in there, turn her on, and now I know I have a PNP. And if I take a bad one that's shorted, at least I can tell that it's dead. It doesn't matter. Also, this one's doesn't matter which way it goes in, it'll still tell you the same one. So, can't really test these T03s in there, but I can set it up on this breadboard and just test over here. So I'll stick this one in there, hook up my wires remotely here, and one last wire, and that tells me I got an NPN transistor. Now I know this one's a silicon transistor. The only problem is with germanium transistors, they don't test exactly the same. If I stick it in here, this is a brand new one. Well, not really brand new, but it's new old stock, and I know it's working because I had it in a circuit a little while ago. If I touch it to there, I'll get that lit up, but because of the way the germaniums work, I get some of the other ones lit up on that side, but I highlight on that one. So this one's actually working. So let's test the first one from our power supply. Put that in there. That's good. Yeah, that's good. So that tells me that it's at least working. Now a second test I can do, turn this off, remove that and that, put that to the side, is this with this little circuit here. A quick explanation, basically it's just a couple of diodes of power going in, going through my transistor there to an LED with a load resistor on it and a resistor there. So this is basically a current limiting arrangement for the diode, for the transistor. So if the transistor is working properly, I should see a little bit of current going through there because there's always some leakage with germaniums. But when I connect them, I should be able to turn that switch on and I should see a higher current coming through. So turn on my power supply here. Go up to say 5 volts. We get a little bit of a light there because there's just some leakage in there. If I put this on there, it should light up brighter, telling me that it's turning on. And it doesn't matter what I do, hands and thing, that light will stay on at the same brightness at the constant current until I drop down to about 1 volt, which turns off the LED. Right. So it keeps a constant current in there. Likewise, if I put the voltage way up, it doesn't change. 16, same amount of LED light. And it drops off at about 1 volt. Well, that tells me that's a good transistor. And the same thing you can see with this germanium. A little bit of a light. Touch it there, I get a bigger light. It should just cook off at about 1 volt. And then go all the way up to 20 volts. Doesn't do a thing. Oop, stays lighted. So, one good transistor. Let's walk through the rest of them now.
Much later.
Our little LED comes on light at 16 volts. Stick that in there, and it comes on brighter. Alright. So, all the transistors, the power transistors are okay. Good. Well, good, but that's not the problem. Now I gotta go find out why the damn thing's not working, because it's not the power transistors. Off we go back to the bench. So testing these transistors proved to be a little problematic. You had to pop them out of the... let me zoom in a bit here. That over. Okay. So testing the transistors on the board was a little more problematic. I didn't really want to unwire them from these binding posts. So, but you pop them out of the circuit. You got enough room, just enough room to stick in your probe under the heat shrink, and then if you carefully go over and touch the other side without getting in circuit with something else, we'll get the voltage drop. There we go. And I think we can get away with this one. Yep. Ugh, problematic, but it can be done. Yeah, 0. And this one should be a diode coming out. Yeah. Alright. So that kind of works. I have to go do that with the other ones. It's going to be funky time, though.
Much later.
So I was doing the last of my diode checking here. There's 2 diodes here. That one's okay. That one's okay. This one, the forward voltage on this one's lousy. It's only 1.8, 1.1. But when I go to this one, I get no forward voltage, so it's telling me it's open, I think. And if I do a continuity check against these 2 posts, oops, that's not good. So I think this diode, I'm dead. I'm going to clip it out and then see if that changes anything. It's just a regular dumbass diode. So we'll clip that out, see what the hell it is. I'm going to keep the leads long so I can twist a pair in the next time I need. It's one piece. And the diode is going which way? That way. So stop current from going left to right, obviously, because you don't want your to be shorted out. That would be shorting out the power rail all the time. So that might be causing us problems. What is this thing? 1N53. 1N538. Okay. Let's look that one up, see if I can get a replacement. Leave that off for now, because that's really just a voltage stopper, or prevents you from getting voltage going the wrong way. So I'm going to plug this in again on the Variac. I'll get that all set up and see if we actually get any voltage out of it. Be right back. Okay, I'm all set up for my test to see if we actually get voltage after we took that diode out. I'll throw the master power on. I got all the verniers and the voltage current adjust over to the side. It's on volts. It's on 50 volts. Let's throw the switch. Got a red light, a little movement there. That's good. We got 1 volt, which is even better. Hey, it's actually working now. Hooray! And clock's all the way up to 50 volts and stays nice and steady at 50 volts. Let's see about the amperage. Amps drops down. What if I get any? It doesn't look like it's working. Might be. No, I don't think that's working. Nope. That's not working, so we'll have to look into that later. I'm either not hooking it up correct or something else. Anyway, we got voltage.
It turns out that 1N536 diode hasn't been made for about 25 years. So reading through the data sheet, I quickly discovered it's just a simple rectifying silicone diode, and I just have to find one from the vast pile I have that is compatible with it at 200, 140, and 200 voltage DC. And in about 10 minutes searching through my stock, I found a 6A2, which was exactly what I needed. So I just did the swap. The only difference being the 6A2 is a 6 amp rectifier, while the other older one is only 5 amps.
So this thing really needs a load. So I just made a little dummy load here with a diode and a couple of resistors, just to give me some sort of load. And the only way this works, I've discovered, is you have to turn it all the way off. Both voltage and the vernier, and then you throw her on, and then you can change the voltage, and there we go, up to 10 volts, and it's still working fine. And my little test circuit is glowing away happily. Okay, so Now to figure out why amps isn't working, but it might be. Amps might be working. It's because it's not drawing much power. Yeah, it could be it. But what really isn't working is the 5 volts. Nothing. So that's what I have to investigate next.
Much later.
So we're looking at the switch, and it's now in 50 volts. So I think these two, put it in continuity. Nope. Nope. Okay, so 50 volts, those two latch up. Turn that on, that would be 5 volts. So that should link that one to that one, or this one. No continuity there, so it's not getting any voltage at all when it goes in. So I think that switch is dirty. Okay, got the good old deoxit D5. There should be a hole right in top to put that in. Volts. Nope. Hey, there we go. Cleaned it up nice. Let's see if that fixed it. Believe it or not, that's all the defects that are on this. Plug in my dummy load again. Voltage adjust to 0. Turn the master power on. Power 5 volts. Let's see. Nope. Nope. Nothing yet. Oh, well, maybe. If I put it on amps, voltage. Nope, nothing yet. So, we have to go further down the line. Pity. Yeah, well, more ohming out.
Much later.
So even after a thorough cleaning, these switches are still on S. They always link just a little bit. And one side is really loose. So, I just swapped it out for another single throw, double. It should be a single throw, single pull, single throw, whatever they call it. Which this is. So this is the common down here, and left and right on top. So all you have here is you have the common in the middle now, and then left and right on top. I got that set to the 5 volts. I've just tested it. I'm going to put it back in. Now, given that this one's dead, that's probably explaining why the amp and voltmeter isn't working to snuff either. I'm going to take that one out too, and see, that one down here, and see if that one's giving us trouble. And see if we can get the current sense adjusted. Alright, be right back when I get that back in. So basically all done with this job. So in the end, the only thing that was wrong was that one diode in there. And I swapped out these two switches, and I can show you them working now. Throw that like that. Make sure it's in voltage. Turn it on. Wait a second or two. And you can slowly power it up to 5 volts. Or you can lower it all the way down with the vernier. Yes, it's a little high. It reads about 1 volt high. Not much I can do about that. So when we flip over to 50 volts, it goes way down. Likewise, it goes way up. We'll spike it there. Yeah, so that switch is working fine now. Good aircraft switch. As for the amp one, I kind of got it working, but I really don't have any load that can push it more than about 150 milliamps, so I'm not sure if it's working. There's also a special way to set it up using the ground and the 2 test leads and the negative sense and the positive sense, and without the instructions I can't do it. Anyway, I talked to the guy that owns it, and he said he's fine with the way it is as long as he's got about 50 volts coming out of it and he can use it for some of the stuff he's working on. He's happy. So I'm going to put it back in its box, well, actually just in the box that it came in, and then ship it back to him. And that's this project all done.